Okay, we are tuning in our discussion here on significant figures. We got towards the end. Again, let me go over the rules very quickly. Four rules for assigning significant figures. Um, First one talks about digits other than zero are always significant. That is the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 individually. Zero is not in and of itself a significant number. It depends on where it's placed. For example, if you look at number 2, the final zeros after a decimal place is always significant. For example, if I have um, 2.0, that 0 is significant. The zeros between two other significant digits are always significant. 202, that 0 in the middle of the two twos are significant. 0 used only to space the decimal are never significant. For example, if I have 1.03, that 0 is not significant. Okay. All right. Here, this comes from an example within your textbook in relationship to significant figures. It says 1.4 grams, and this is on page 129 in your textbook, of hydrocortisone powder are needed to compound the prescription. The question here is how many significant figures are in this measurement? The answer is since final zero after the decimal point are always significant, the significant figures is 3. So if you look over here, your significant figures will be 3. So 1, 2, 3. Why? Because since the final zeros after decimal points are always significant, the significant figures in this particular example is 3. Okay, let's look at the different examples in relationship to the systems that are used. And we will go through them in details. So when we talk about measurements, we're talking about there are different systems of measurements in pharmacy. The one that's mostly used is metrics, but you also have English, apothecary, and aporeposis. So the metric system is the primary system that's used as mentioned. Within these systems, there are different measurements for weight, volume, and mass, as well as for liquids and solids. There are also different measurement systems for temperature. It is necessary to know how to perform conversions, and we're going to look at some of the conversions. How to convert one type of measurements to another so that both amounts are equal. Okay? So let's go ahead and begin our process of looking at the metric system as relates to liquids. So this is something that you should be familiar with, and you should be familiar with conversions. So L is liter, DL is deciliter, ML is milliliters. You see that this punctuates many of our um, scientific instruments that you see in regards to volume. The conversions, as you can see here, 1 liter is 10 deciliter, which is 1,000 milliliters. 1 deciliter is 0.1 liter, or 100 milliliters. And 1 milliliter is equal to 0.001 liters, equal to 0.01 deciliters. And let's look at the metric system in relationship to solids. A kilogram has a symbol of kg. grams at G, milligrams, mg, and the micrograms, you find mcg, or the symbol mu, which is Greek, in front of the G. Solid conversions, 1 kilogram is equal to 1,000 grams. 1 gram is 0.001 kilograms, or 1,000 milligrams. 1 milligram is 0.001 gram, or 1,000 micrograms. 1 milligram is equal to 0.001 milligrams, which is equal to 0.000001 grams. Okay. Here, this is part of the English system, and this is related to solids. And you probably see this, and this is a system that's used within the United States. And I believe Liberia and one other country is basically the only country that still use part of the English system. And a pound is equal to lb, ounce, oz, grain, gr. You can really see this particular symbol that much in even in our English system that we use for solids. Conversions, 1 pound is 16 ounces. 1 ounce is 437.5 grain. 1 grain is equal to 64.84 micrograms, or 0.00648 grams. And as you go and listen to this particular lecture, we cannot put all the calculations here. I want you to now go to your textbook and do all the problems within the textbook. It will be a very good reinforcement of what we're talking about in relationship to this particular chapter. The apothecary system here, again, part of the English system, liquids, unit here, for example, gallon, the symbol is GAL, quart, QT, pint, PT, ounce, FLOZ, fluid gram, FLDR, and minim, which is found, which the symbol is MIN, or M with a underscore X. Conversions that you probably have been familiar with is 1 gallon is equal to 4 quarts, a quart 2 pints. 1 pint 16 fluid ounces, 1 fluid ounces is 8 fluid grams, and 1 fluid gram is 60 min. We don't really see fluid gram or minim much, but gallons, quarts, pints, ounces you can find a lot. Okay, let's look at some of the household units, and this is again used much within the pharmacy setting. You may see a teaspoon, and that's TSP, tablespoon, TBS, cup is just cup. The conversion is 1 tablespoon is 5 milliliters, 1 tablespoon is 3 teaspoons or 50 milliliters, and 1 cup is 8 ounces. Something that's also very important to know in terms of conversions. Again, in the United States we use Fahrenheit for the most part, but Celsius is used worldwide. Fahrenheit is equal to 1/4 times the number of degrees Celsius, plus 32. Celsius temperature is equal to 5/9 times the number of degrees Fahrenheit, minus 32. And let's go ahead and take a quick look at this as an example. This said that it was 32 degrees. What would be the Celsius temperature? Well, it's 32 minus 32 is 0. And anything multiplied by 0 is 0. So 5/9 times 0 will give you 0. So when it's 0 Celsius, it is 32 degrees Fahrenheit. Okay. So using Fahrenheit here, it's 1.45 times 11 degrees Celsius. So if I did this, if I said 100 degrees Celsius, which is boiling, times 100 and 1 4/5. Okay, then add 32, and then up with 212 degrees Fahrenheit, which is boiling Fahrenheit. Okay, so that's the conversion between Celsius and Fahrenheit, and vice versa. Okay, this is something that's very, very important. You should be familiar with in relationship to working in the pharmacy. This is called ratio of proportions. So understanding ratio of proportion is important for pharmacy technician. If you understand ratio of proportions, you will be able to perform most calculations necessary for your job. And you define a ratio as a relationship between these two quantities, such as the ratio of A to B can be stated as A over B. And two equal ratios are called the proportion. For example, A over B, such as in a fraction, is equal to C over B, as in a fraction. Okay. Also, your book goes through many problems that you should do, and that will help you with your work. Okay, so let's go ahead and look at percent and solutions. All right, so percent weight to volume. That's talking about grams per milliliters. For example, if I have 15 grams per milliliter, my percentage is 15%. Volume to volume, if I have something that is 50 milliliters in per 100 milliliters, then that would be 50%. Then we will talk about milli equivalent, and we have a few formulas that will help you understand milli equivalent. Okay, well, we have it right here. Concentration of electrolyte in a volume solution is equal to milli equivalent per milliliters per liter. Specific unit of the measurement that cannot be converted into metric system. And different electrolytes have different milli equivalent values. And this is based on electrolytes' atomic weights and electron properties. For example, sodium chloride has a milli equivalent of 1. Okay. Same of something like magnesium sulfate. An electrolyte is something that when you place in water, kind of dissociates into positive and negative components. For example, again, using salt, if you have sodium chloride and ACl, and I put that in water, it becomes an electrolyte where sodium, which is positive, will be surrounded by water molecules, more specifically it's oxygen that has a bond with the positive. Oxygen is negative, sodium is positive. Let's go into a little bit of chemistry here. And then you have the chloride, which is negative, will be attracted to the hydrogen with the water molecules. You almost will be surrounding that chlorine molecule. So there's a dissociation that occurs in the aqueous solution of sodium and chloride. And here are some of the common electrolytes: sodium chloride, magnesium sulfate, magnesium being positive, sodium sulfate being negative, potassium chloride, potassium being positive, chloride being negative, potassium